Hello, class. Today we're going to learn about work and energy. Energy is a quantified number describing a system. Most of you have probably heard this statement before, that in a closed system, energy cannot be created nor destroyed, but it can be transformed into different types. The different types of energy are mechanical, which can be broken down into kinetic and potential, thermal, electrical, nuclear, chemical, and sound. So, in a closed system, energy can be transformed from light to the chemicals that make up a carrot, from electricity to heat up your pot of soup, from chemicals in ice cream to give the biker energy to move, and the chemicals of gasoline and the engine to make the car go vroom. In each case, energy is not created nor destroyed, but just transformed into a different type. The type of energy we're going to analyze in this chapter is mechanical energy. The first topic we're going to learn is the definition of work. Work means the transfer of energy from or to an object by means of a force acting on it. So energy transferred to an object is positive work, and energy transferred from an object is negative work. The equation for work is the force component along the direction of motion times its displacement. This can be represented by the force times displacement times cosine theta. The figure below represents that we are multiplying the force parallel to the displacement. This parallel force equals the hypotenuse F, force times cosine theta. The unit we use for energy and work is joules, which equals newtons times meter. When we calculate work, we pick one force. So in the example on the left, we can state what work is done by the man holding the bag, or we can state that what is work done by the weight of the bag. Can you guess what the work is on either of these forces? Correct, 0, because in either case, the force vector is perpendicular to the displacement. So there are no components parallel to the displacement. Here's another example of 0 work done by gravitational force because it's always perpendicular to the direction of motion. Let's analyze work done by the force push and the force friction. The work done by push is positive because it's in the same direction as motion. And if you think about it, it creates motion to the object. So therefore, the value of work is positive. On the other hand, if we look at the work done by friction, it's negative because it's the opposite direction of motion. And again, if you think about it, friction is slowing down the motion of the object. So therefore, the value of work is negative. Another way to rewrite the equation for work, instead of F times displacement, is 1/2 mv squared of the final position minus 1/2 mv squared of the initial position. This is done by changing force to mass times acceleration and substituting in a kinematic equation. We define the 1/2 mv squared as kinetic energy. Kinetic energy is a mechanical energy that describes the energy of motion. So the second equation for work is really the change in kinetic energy, since we had the final point minus the initial point. So if the change in kinetic energy increases, meaning the motion is moving faster, then we have positive work. If the change in kinetic energy decreases, meaning the motion of the object is slowing down, then we have negative work.